We are now module 2B. We are still working with rational equations today. So let's recall, what does the word rational mean? Very good. The word rational has the word ratio in it, and ratio means fractions. So a rational equation contains fractions. We saw already in the previous module that that's not a problem. We can get rid of fractions by using the least common denominator. What you're going to see in this module, though, is now in the fractions. Instead of the variable x being in the numerator, it is now going to go to the denominator. And that's going to play a little game. It's going to change up our directions. No longer the direction is just going to say solve for x. Now the directions are going to say something called state the restrictions. Okay, I'm going to go to the notes so we can talk about that. So in your class notes, it says, sometimes the variable can be located in the denominator of your fraction. You have to understand, remember in algebra, that variable x is supposed to be representing a number. But we've learned in arithmetic, going back to 3rd grade, what number can never, ever, ever be in the denominator of a fraction? Very good. That's the number 0. Because if you think about it, if I have $6 and I ask you to divide that into 0 groups, you can't do it. Okay, you've all heard the word undefined before. And the word undefined means when you cannot divide. And the only number you can never divide by is 0. So it's going to be really important with today's equations that we make sure that letter variable x is never the number 0. So the first thing you're going to hear in the directions is called state the restrictions. And the important thing about that is when you hear the word state the restrictions, all you got to do is think about the denominator, because that's all it's concerned about. We have to always make sure the denominator of fraction stays a number other than 0. So let's go to the whiteboard and look at the first example so we can make sense out of this, because I know speaking doesn't make any sense until you see it. So we're going to look at example 1. Okay, here is my rational equation. It's got fractions. What's different now in module 2B is the variable x is in the denominator. So the directions don't just come out and say solve. The first thing the directions ask for is state the restrictions. When they say the word state the restrictions, they're only dealing with the denominators. So what are your denominators? They are 2x, 18, and 3x. All right, let's talk about this. Out of those 3 denominators, there's one that's fine, and that's the 18. If I have something in real life, I can ask you to divide it into 18 parts. That denominator is a positive whole number, so that's acceptable. It's these other denominators that we have to be careful of. This denominator is not a number. It's an algebra expression. It's 2x. And whatever number x is going to change what this denominator is. For example, if we find out x is 1, this denominator will be 2 times 1 times 2. And you could divide 5 into 2 parts. If we find out x is 2, this denominator would then be 2 times 2, which is 4. And you could take 5 and divide it into 4 parts. But we've got to make sure is that this denominator never becomes the number 0. Because if I have 5 and I say divide it into 0 groups, you can't do that. There is no answer to that. That's why we called this in elementary math undefined. That means there's no answer to it. You can't do it. So when we say state the restrictions, we're asking you, what number would go in this spot that would make this become 0? That would make this equal 0. Now, you could think about it. 2 times what is 0? Very good. It's 0. Or you could just solve that by dividing by 2. And 0 divided by 2 is 0. This answer here is the restriction. Now, not only do you have to get the restriction for this fraction, you have to do it for this one also, because there's a variable in the denominator. So if there's a variable in your denominator, you have to look for a restriction. What can x not be? So again, this is 3x. I'm asking you, what's going to make this denominator become 0? You could think about it, 3 times what would give you 0? Or you could just solve this. And what is 0 divided by 3? It's 0. So on this equation, your restriction is the number 0. X cannot be 0. That cannot be the answer when you solve this equation. Okay? That's what they want to know up front. What can the answer not be for this equation? That's what we found out. Now we're going to go to the second part. The second part says solve it. Well, to solve this, we've already discussed you need a least common denominator. So now we have some algebra. In your denominators, you have a 2x, a 18, and a 3x. And the least common denominator is not just a number now, it's also going to have a variable. So if you look at the numbers 2, 18, and 3, what can they all divide into? You're right, that's 18. But if you look at these denominators, we have an x, no x, we have an x. The question is, do you take both x's for the LCD and make it x squared, or do you just need one x? Well, let's go back to arithmetic. If I had the fraction 1/4 and I had the fraction 3/4, and I asked you what the LCD of 1/4 and 3/4 is, it would be the number 4. So even though you physically see 2 4s, 1/4 and 3/4, there's 2 4s there, you only need one of them. So when you do the LCD, you want one of every term. So I need the x. So that's your LCD. We're going to take that and we're going to multiply it like we've been doing. Okay, now we're going to do our dividing. 2x divided by 18x is 9. So 2 goes into 18 9 times. If you remember from algebra, x divided by x cancels out. So that's going to leave us 9 times 5. Over here, 18 divided by 18 is going to cancel out. It's going to leave us x times 17. Third term, 3 goes into 18 6 times. X divided by x cancels out. So that leaves us negative 6 times 1. And now you no longer have a rational equation. There's no fractions, so it's linear. We're going to multiply. Do we write x times 17? Nope, we write 17x. Now, what side do we like the x on? The left. There's a little trick that I always show my class. I show them, guys, an equation is a balance. It's like a seesaw. So think about this. If you had kids were playing on the seesaw and it was balanced, and they switched sides, it would still say balance, correct? Just like if you were lifting weights. If you had weights and they were balanced and you picked them up from the other way, they would still be balanced. So look what I'm going to do. I'm going to take the whole right side and put it on the left. I'm going to take the whole left side and put it on the right. It's the same equation. Flipped it over. It's still balanced. But now that lets my x be on the left, so I just have to add 6. That makes 51. We divide by 17. And 51 divided by 17 is 3. Now, what's great about this is I just have to double check myself. Can the answer be 3? Well, you set up here the restriction was 0, which means the answer could not be 0. Is that the number 0? Nope, it's not. So that is our solution, our answer. So what's important is solving is using the least common denominator. The restriction is looking at the denominator. All right, let's look at our notes and try the next one, because I know this is kind of silly, kind of confusing. We got to go slow. So if we look at our notes, the next rational equation, they're getting a little bit more complicated. So let me write it down. Equals. So we have x over x minus 2 equals 2 over x minus 2 minus 2/3. If you look, it's a rational equation. There are fractions. The problem is, look at your denominators. You have a variable here. You have a variable here. So we got to worry about what numbers cannot go in that spot. Think about it. Can you put the number 3 here? Sure you could. 3 minus 2 is 1, and you could divide something into one group. Could you put the number, I don't know, -4 in there? Sure you could. Negative 4 minus 2 would be negative 6. Well, the negative would rise to the top and you would have divide by 6. And in real life, you could divide something into 6 groups. What we're worried about is what's going to make that become a 0. So the first thing you see in the notes is says, what are the restrictions? So we're going to look here. What would make this denominator equal 0? Now, you could think about it. What number minus 2 gives us 0? It's 2. If you don't want to think, just follow your procedure and solve. There's your restriction. That's your restriction. X cannot be the number 2. Now, do we have to do the restriction here? Well, technically, yes, because there's an x. But if you look, this denominator is exactly like this one. So this would have the same restriction. We don't need to write that twice. We got it. The number x cannot be is 2. The third denominator is what? It's a 3. Can you divide something into 3 groups? Sure you can. Because that's a number and there's no variable, we don't got to worry about it. All right, now that we got the restriction out of the way, now that we decided what x cannot be for the answer cannot be the number 2. Now we're going to do the solving. To solve again, what are we going to need? Our LCD. Our denominators are x minus 2, and 3. Now I know that's crazy because you're thinking, oh, it's algebra. Think about arithmetic. If the denominators in arithmetic were 2, 2, and 3, what would the LCD be? It would be a 6, right? You would need the 2, you would need the 3, and 2 times 3 is 6. So this is the same. We don't need both 2's, we'd only need one of them. And this is different. We need that. So the rule about getting the LCD is you find every different term and you multiply them together. So if you look here, in our denominator we have an x minus 2. It's repeating. We don't need both of them. We only need one of them. And we also need the 3. And this is connected by multiplication. So that's your LCD, 3 times x minus 2. We're going to put that where? Very good. We're going to put that in our numerators. Every numerator is going to get a 3 and an x minus 2. All right? Now look at me. We don't have a lot of work to do here because this is all multiply and there's your bar. There's divide. What's the same that's going to divide out? Well, in algebra, if you divide the same terms, they cancel. So that cancels the x minus 2's. You're left with 3 times x equals x minus 2 and x minus 2 is the same term. So we're left with 3 times 2. In the third fraction, the 3's cancel out. Now this is important. You're left with negative 2 and then the parentheses, x minus 2. Do you see any more fractions? No, you do not. So guys, you're no longer rational, you're linear. We distribute to get rid of our parentheses. So negative 2x, positive 4. Okay, on the right side, we could do some CLT and collecting like terms. We get negative 2x and 6 and 4 is 10. We add 2x. We get 5x equals 10. We divide by 5 and we get x equals 2. Now, I'm warning y'all. We already in the beginning stated our restriction. We said at the beginning, the restriction is x cannot be 2. We told ourselves in the beginning the number, the answer, this cannot be the answer because if we put a 2, 2 minus 2 would be a 0 and you can't divide into 0 groups. It doesn't make sense. So guys, even though you did all your work beautifully, this is not the answer. There's a name given to this. When you get an answer that doesn't work, it's called extraneous. That word means useless. This is a useless answer. It is no good. It's like garbage. You have to cross it out and throw it out. And that's what you're going to find out now in college algebra, what's going to happen. You know, you've been spoiled. In Algebra 1, when you solved an equation and you got an answer for x, it always worked unless you made a boo-boo. Okay? In college math now, we're in a whole different world. You could do everything precisely correct on your paper. there's no guarantee the answers you get out are good. They may be extraneous. And you'll know the answer is extraneous if you're dealing with an equation by fractions, because that's why you're stating the restriction up front. So guys, here's the problem. I want to know what the answer is. I'm asking you, what is the solution? Well, if you throw that in the garbage, do you have an answer for x? No, you do not. So there's a famous phrase we use when we have no answer for x, and it's the famous no solution. That means there is no answer for x. And the symbol for that is the digit 0 with the slash. So I know in the military world they use this to represent a 0, but in math that is not a 0. That is a symbol for this phrase. And you can only use this symbol when you're working an equation and the answer you get has to be thrown out and you have no answer. So we would say here we have no solution. All right, we have one more rational equation to look at. And now we're really going to get to the college algebra. As you look, I'm trying to bump you up a notch. All right, so let's look at the last one. So we're building on everything, and we're just making them a little bit more intrinsic. So look at our last example. 4 over x plus 5 plus 2 over x minus 5 equals 32 over x squared minus 25. Ugh, that is an irrational equation. It has fractions in it. Okay, if you look closely, where are your variables located? In the denominator. So now we got to make a decision. We know the denominator can never be what number? 0. Very good. So that's the first thing they're going to ask us, is for the restrictions. So we're going to take the first denominator, x plus 5. What's going to make that 0? Well, we all know it would be in negative 5. Negative 5 plus 5 instead of 5 would make a 0. So we know the one answer. We know the answer cannot be negative 5. This denominator is different, so we have to get a restriction for it. So again, a restriction means what makes the denominator 0. So we'd add 5 now, and x equals 5. And that makes sense. If the answer was 5, 5 minus 5 would be 0, and then this fraction wouldn't exist. So now we don't have one restriction, we have 2. The answer cannot be negative 5, the answer cannot be positive 5. But wait, we have a third denominator, a third fraction. Now, here's the important part. If you went through the developmental series, you learned back in Algebra 2 factoring. Factoring is a way to break down algebra, and it's connected by multiplication. What you got to realize in college algebra is you never know when factoring is going to come up. No longer are the directions going to say in college algebra, hey guys, factor this. You've got to understand factoring just breaks down polynomials. So what happens here is, to figure out what the denominator cannot be, this factors. And if you remember, it breaks down into 2 parentheses. What multiplies to x squared? X times x. What multiplies to 25? 5 times 5. To multiply to a negative, one has to be positive, one has to be negative. So we're going to use our factoring skills. This was the rule called difference of perfect squares. Difference has a subtraction symbol, and a perfect square means something times itself. Something times itself. Well, if you factor that denominator, you'll realize we have no more work. This part of the denominator looks just like this. We already got the restriction. Can't be the number negative 5. This part of the denominator looks like this. So we already got the restriction, x equals 5. So guys, this is important. You're going to use those factoring skills throughout the whole college algebra course. The problem is it's not going to come out and say, hey, factor. You got to realize, hey, I can factor. Why don't I use that to make it easier? So I've learned now that for this rational equation, there's not one restriction, there's 2. And this is an x squared, and you also remember the 2 means 2 parts, 2 restrictions. All right, now the restrictions are out of the way. Now they want us to solve. Well, to solve, we need that concept LCD. We have in the denominator x plus 5 and x minus 5 and x squared minus 25. All right, this term and this term are not the same, so we need each one of these. This term doesn't look like these two. But again, here's another thing. You learned in good old Algebra 2, 99, that when you get an LCD, all your denominators have to be in lowest terms. They have to be factored. So you got to recall that this factors to be x plus 5 and x minus 5. So what you got to realize is to get the LCD, you need 1x plus 5 and 1x minus 5. This term breaks down, and that's important. So you're going to need your factoring skills to help you get the LCD. So the LCD is going to be, you need an x plus 5 and an x minus 5. You need an x plus 5 and an x minus 5. X plus 5 and an x minus 5. Now look what happens. We're going to have something that's the same that's going to divide out. X plus 5 divided by x plus 5 makes a 1. It's gone. Now, we have an x minus 5 in parentheses times 4. The 4 should go in the front. Second fraction, the x minus 5s are going to cancel out. We're going to have the plus, we're going to put the 2 in the front, and we're going to have an x plus 5. Now, somebody's going to say, well, nothing cancels out here. Yes, it does. We just talked about now 2 times that this polynomial factors to be x plus 5 and x minus 5, which means the x plus 5s are going to cancel, the x minus 5s are going to cancel, and that's just going to leave you 32. Now look, there's no more fractions. You're linear. Now you're back to Module 1. Distribute. Distribute. So 4x minus 20 plus 2x plus 10 is 32. Let's CLT. Let's collect like terms. 4x plus 2x is 6x. Negative 20 plus 10. You would have to subtract. You get negative 10. Your variable's already on the left, so you just got to move your numbers to the right. 6x equals 42. Divide by 6. X equals 7. Now, can that be the solution? Yes, it can, because we set up here the restrictions were negative 5 and positive 5. Up here we stated what could not be the answer. This is not a negative 5 and this is not a positive 5. This is good. So what is your solution? 7. 7 is the number that when you substitute it in makes this equation balance. Okay, so now we're done with rational equations. We will see them pop up throughout the semester in college algebra. So don't think we're finished with them. They'll pop up all throughout the semester. So we went through the basic concepts. All right, I'll see you in Module 3.